Welcome to Setting the Standard, brought to you by the Wireless Innovation Forum. I'm your host and Communications Director of the Forum, Stephanie Hamill. Today, I'm diving into how our standards are created with Forum CEO Lee Pucker. So today I'm talking with Lee Pucker, CEO of the Wireless Innovation Forum. Lee, thanks for joining me today.
Sure, my pleasure.
All right, so what I wanted to talk to you about is our lean standards development model. Can you give me an overview of what it is?
Sure, the model stems from how products are developed in the commercial world. There's the concept in the commercial world, in commercial product development, of minimum viable product. And basically what that is you put out a product that has the minimum number of requirements met, use that to gather information and feedback on what changes and what new things need to be done. You put out another revision quickly that has those new features and capabilities. You get feedback on that. You put out another revision quickly, and so on. So you're always making small incremental changes to the product as it evolves. We've taken that concept into the WIN Forum, and we've developed what we're calling our Lean Standards Development Model. It's basically what's the minimum standard that you need in order to get something commercialized and get the technology into commercial development, and then taking that standard or that technology that's been put out into the field, getting information back on what's good, what's bad, making incremental changes, publishing another release of the standard, and just doing small incremental changes to the standard over time to get to where your final goal was for that standard.
Okay, so what do you think the advantages are that it has over other standards development models?
So traditional standards development models, you try to think of every possible situation that could ever occur in conjunction with that standard. You develop the standard to address all possible situations, whether they're going to occur or not. Most of those situations, it turns out, never happen. So a lot of the standards that are published have a lot of features in them that are just never used because, engineers like to put things into standards that aren't actually necessary from a commercial deployment perspective. So the difference is our standards, you can actually get a standard from concept to published in 3 months. And we've had standards that have been developed in that short a period of time. Other organizations take 3 years. And the reason they take so long is because they're trying to capture every possible scenario that can occur with that standard. They're trying to capture every possible thing that they can foresee that would occur when the standard is in deployment. And there's a lot of discussion around that, making sure that through the process that they've covered all the bases. So 3 months versus 3 years, and those are the kind of the differences that you get with our model.
Right. So it's just really responsive and a little more flexible.
Exactly. And in fact, if you look at some of the standards we've developed the CBRS standards, for example, you'll see that by the time the FCC pulled the trigger and for full commercial deployment, our requirement standard was up to version 1.9. So we were on the 9th revision of that standard because we had done this process where we start with a little and then make changes as we learn things going along. The other thing that's nice about this model is it allows things to be done in parallel. So the normal process is you develop your requirements, stop. You develop your protocols associated with that, stop. You develop the tests and certification associated with that, stop. Then you all go all the way back. What we found that we've been able to do with our Lean Standards Development Model is you can actually start with the requirements, but after you've got into it a little bit, because we're publishing these things so quickly, you can start the protocols in parallel, and those can be going on while you're working on the next revision of your requirement specification, and the test and certification can then be started and worked on the protocols as they're developed while the next iteration of the protocol standard is being developed. So you can have things being done in parallel in following our model, whereas in other more traditional waterfall models, you'll find that everything has to be happening serially.
Right. So let's talk about CBRS, and can you give us a little bit of the history there, and then also look at where it's heading?
Sure. So CBRS, as an example, we developed in a pretty short period of time. In a period of 3 years, our members developed 10 standards. They developed standards, requirement specifications. They developed standards for security, protocol standards for moving information between the various elements of the CBRS system. They developed standards for the various databases that had to be used. They developed test specifications for certifying the Spectrum Access System and certifying CBRS devices. So 10 standards in all were developed. Many of these standards had gone through, in that 3-year period of time, multiple iterations. So from the time from 2016, I think, to 2018, 10 standards were put together. The complete protocol package was created. The complete test and certification package was created. We were able to take that and develop test harnesses and test suites. Our members were able to do that. Because this was developing iteratively, they were able to get that done. So it was done roughly at the same time as everything else, all done in parallel and available for the equipment to go into the certification process at that time. Moving forward for CBRS, the same model is being followed for what we're calling Release 2, or the next generation of CBRS standards. But the difference here is that we're taking it another level. So instead of having sort of a baseline specification that had to cover everything, we're developing standards on a feature-by-feature basis and publishing them. So somebody finds in the field they need a new feature, a new capability for the CBRS system. We can develop a specification just for that feature, the protocols associated with supporting just that feature, and testing of just that feature. And then all the features are optional. So the radio manufacturers, the Spectrum Access System administrators, everybody in the ecosystem can choose which features they need to support for their specific business needs and adopt those features, that subset of features, because all the baseline features are completely a la carte.
That seems pretty visionary. Have you seen that being done anywhere else, or any other?
It's a bit of an experiment. I actually haven't seen that done anywhere else. So we came up with this to try and as how we're planning to support the needs of the ecosystem as it evolved. We found that different market verticals had different needs for different features. We didn't want to build a one grandiose standard that supported everybody. And so it seemed to make more sense to allow these a la carte features to be added in as needed to allow us to, or to allow the industry to do what they needed to do to support their specific market vertical. The only thing that's common across everything in Release 2 is a capability exchange, where we're allowing or we're requiring the radio devices and spectrum access systems to exchange their capabilities of what features they can support at the beginning, at the initial handshake between the two. That's mandatory for Release 2. Everything else is completely optional.
Okay, that's fantastic. Now, how do you think this can translate into different bands or different technologies or anything applicable in the future?
Sure. So the same kind of model can be followed for our committees that are working in software-defined radio systems and software-defined systems. Same kind of model can follow there. And also we can follow the same model. We've got a new 6 gigahertz committee that's just starting to look at, right now they're working on technical reports, but as they move into specifications moving forward, our anticipation is they'll be following this model as well, again, because they want to get things out as quickly as they possibly can.
All right, thanks, Lee, for joining me today, and I look forward to talking to you about more wireless topics in the future.
Thanks, Stephanie.
Have a great day.